Hello. Welcome back. If we just take a seat, we're starting for the final session of today. So, yeah, Lee, if we can sit down, please. Cool. Okay, so welcome back to the end of today's session. Welcome back online as well. We've got 4 talks for you in this last session, and then Zoe's going to wrap up, and we'll tell you about the social later this evening. So first up, we've got Rosemary. Rosemary's from Public Health Wales, and she's going to talk to us about what she learnt by building bilingual websites. So over to you, Rosemary.
Thank you very much. So I thought I'd start with a bit of audience participation. We all probably need it after the coffee break. Feel free not to answer this question if you don't want to, but if you're happy to, if you could stick your right hand in the air if you speak a language other than English, and your left hand in the air if you know anybody who speaks a language other than English. So I think it's pretty clear from this that in our communities there are lots of people who speak languages other than English. But if you hang out in tech spaces online, you might not realise it. And so what I want to talk about today is a couple of experiences I've had building websites with multilingual functionality and kind of what I've learned through that process. So as Rhian mentioned, I work at Public Health Wales and as part of my job, I've built an evidence map. I've helped to build an evidence maps application. And as a public sector organisation in Wales, Public Health Wales is subject to Welsh language standards, and what that means is that everything we publish treats the Welsh language and the English language equally. So we had to work out kind of how to do that. So in terms of a tech stack for the application, we were using the Django framework in Python and GitHub and Azure. And in terms of our user needs, our users needed to be able to access evidence maps content bilingually, and by evidence maps, this is something our evidence service produce, which is basically a sort of overview of the evidence that's available on a particular topic. And we needed interactive functionality to be supported, such as certain kinds of filtering. So in terms of user needs, relatively kind of involved user needs, there are kind of a few elements to that. Something else I've built bilingually is a website for a wedding. This is not a work job. This is not what we do at Public Health Wales. This was for my personal life, and the tech stack was much, much simpler. I was using Quarto and GitHub and Netlify. And in terms of user needs, it was mostly kind of static content we needed to display, but we needed to display it in English and in French, because my partner's family are French, so I need to be able to access that information in both languages. But it didn't need to be super sophisticated, because I was the customer and I wasn't very demanding. So this is just to show what our evidence maps look like. This is a picture of the page in Welsh, and this is the same page in English. This is my wedding website. I've redacted the details just in case you attempted to turn up. And this is the same page in French. So kind of the kind of way I came into this was this: when I started doing these things, I really had no idea what I was doing, and I sort of stumbled my way into it. And I was very much like the person in this cartoon, which unfortunately is probably a bit small to see in the room, but it's basically someone taking on a hard project that they don't really know how to do, and kind of enthusiastically trying to work out how to figure it out. And I kind of wanted to give that context, because this is this question, how you produce content in multiple languages, is something people spend whole lives working on. So this is my sort of beginner's take, I guess. But a bit of vocabulary that you'll find if you try to do this. We talk about internationalization, which means designing an application to be adaptable to multiple different languages or multiple different regions as well. There's a bit more to it than just language. And because people are lazy, rather than writing internationalization out a lot, they write I-18N, because there are 18 letters between the I and the N. It took me a really long time to work out why people kept referring to I-18N. And then localization is then the process you go through when you're adapting an internationalized software into a particular regional language. So that's something point at which much more like people like translators would be involved. And no prizes for guessing where L10N comes from. So this is just a brief summary of what I learnt. And I'll go through and talk about each of them in a bit more detail. So don't repeat yourself, or DRY, is something that gets talked about a lot in sort of software engineering. And what it basically means is that this quote is that every piece of knowledge has a single unambiguous representation within a system. Well, what does that mean? That when you want to go and change something, there's one place to change it. And the reason I think this is really relevant to building bilingually is often you might find yourself building something in one language, and then you realize you want it to support another language, and the temptation at that point is just to copy paste everything you've done, and that's fantastic and it works brilliantly until you want to update something, and then you've got to go into both versions again and update it, so it's a bit tedious. Also, maybe think about separating concerns. Again, this is a really general principle in software engineering that it's good to separate computer programs into sections that do one thing. So it's very often about modularizing a system. But in this case, I think the concerns thinking about separating are the sort of text content from the functionality. Because again, you get to the point at which you want to generate your text in two languages or multiple languages, and you suddenly realize it's embedded everywhere through your system. So you've got to go and look for all the strings that you've left hanging around. And so some of the tools I'm going to talk about later on kind of help. Oh, I need to not attack the mic. Some of the tools I'm going to talk about later on kind of help with this. But again, I think it's useful to sort of take the step back and think about what's going on and why. Another thing I learned is about the fascinating complexity of human languages. And I think it's quite easy to go in with like a can-do attitude and think, great, I can do things, I can make things work. And you can find yourself a little bit humbled by humans and languages. Here I've written a nice little function in R to take a type of pet and to take a number and to return a sentence saying you have and how many pets you have. And you can see I've put in get pet message cat and 2, and it returns you have 2 cats. And get pet message dog and 1, you have 1 dog. And so I'm feeling really good at this point. And then I come to try and adapt my code to a different language. This is a real picture of the whiteboard from my Welsh class. And the left-hand side is the word for dog. The right-hand side is the word for cat. Those are numbers down the side. And you can see that the words are changing, not just for 1, not just for 2, but kind of all the way up to 6. So that's not going to be much good with this code. And this is a kind of well-known problem. And there are some of the tools I'm going to talk about, people have thought about the pluralization challenge. It's actually not so simple even in English, because if you have a pet goose or a pet mouse, this function isn't very good. Human languages are full of interesting complexity. And one of the good things, though, is that lots of people have thought about this before me. And so there's lots out there in terms of reusing existing solutions. So for the evidence maps application I showed, I used the tools available in Django, or we used the tools available in Django for internationalization and localization. And that's reliant on something called getText, where you can basically flag throughout your code what you want to have a translation available, and then you can extract it to a message file and provide the translation there, and then you can do that for each language that you want to support. So that's really nice, and it's kind of building on what other people have done all the way down, because that's based on getText for Python, which is a Python tool, and it's based on the getText, the kind of original getText utility, GNU getText, which is really fascinating because if you go back and look at the documents, it's like from the pretty early days of people doing software, and this is the sort of the descriptions basically go something like, oh, up till now we've just been using English, and we've now kind of worked out that now these computer things are getting popular, we probably need to make them usable by people who aren't speaking English. And yeah, it's kind of built on that all the way. Actually, when I came to do a website in Quarto, there wasn't so much available. I guess it's kind of pretty new, and also the requirements are not so tricksy. Often the Quarto website is a lot of static text, but I did find, luckily people on the internet are very great at putting their code up, and I did find an example of blog post, basically someone describing how they'd implemented it using project profiles, if you're familiar with Quarto, and I basically followed what they were doing. Since then, actually, there's been kind of other people working on this, and there's the Babel Quarto package, but I haven't tried that out yet, so I don't know how that works. A couple of other things. There's not one right way to do things. I did a Quarto website one way. A colleague came to do a Quarto website in 2 languages, implemented it a different way, and both kind of work. And also, it really depends on what your requirements are in terms of the what you need to support. But the other thing is, obviously, I've been talking about the tech elements today, but it's very much not just a tech problem. It's very important to be working with users. If you're interested in the whole questions of how you produce content in 2 different languages, the Centre for Digital Public Services in Wales has some resources I'd really, really recommend looking at. So yeah, to summarise, building multilingual websites is great, and you learn a lot, and a lot of it's generalisable to other contexts. If you want to look for yourself, the Evidence Maps application is available, but the code isn't currently public. Sorry about that. The site for my wedding website is behind a password. Again, I don't want you all to come. I'm so sorry. But I've put a mini example of the code up on GitHub and a few references as well. And that's all. Thank you very much.
Diolch yn fawr iawn, Rosemary. Wyt ti'n dysgu Cymraeg?
Doing dysgu Cymraeg.
Right, we've got some real questions as well. Francesca wants to know, do you release your open source code bilingually? I feel like documentation and testing is hard enough in just English.
That's a very live question. So we're figuring out how we, at the moment, we're figuring out how we can start to open source our code. It's not something we do as an organisation at the moment. And so we're going through a process of working out what we will produce bilingually in terms of documentation. Obviously, code itself is written in a programming language, so even though the words look kind of like English, they're not actually English. But yeah, in terms of documentation, we're working that out. Watch this space. If you do want to see some great examples of bilingual repos, the Language Technologies Unit at Bangor University has a lot of great repos. They do a lot around the language tech, and they've got lots of bilingual repos out there.
Thanks. Another question from Nicola. Do you think the same coding tips would work for having an accessible version? So, for example, like audio described, are there some parallels?
Yeah, that's an interesting question. I'd like to go away and think a bit more about that. Certainly, accessibility is something we've been thinking a lot about as an organisation, so I might ask some colleagues their opinions on that as well.
Cool, thank you. We have a couple more, but I think we'll handle those in Slack, so let's thank Rosemary again. So next up we've got Richard Wood. Is Richard around? Where are you hovering? Oh, there you are. You're fantastic. So digital twins are I feel like a hot topic at the moment. And you're going to tell us about digital twins and using R for digital twins. So I'll hand over to you, Richard.
That's quite right. Thanks so much. Good afternoon, everyone. So going to talk to you about some work. Well, the idea behind this started about 3-4 years ago. But it was only until about a year ago when I had a bit of time to really sit down and come back to this and find the solution, along with my colleague Luke Shaw at BNSSG ICB as well. So about 3-4 years ago, I was running a project with HDI UK funding around Bristol, North Somerset, South Gloss, BNSSG, on complex discharge pathways. So this is typically older, typically frail individuals who are admitted to hospital and they can't leave hospital without some continuing ongoing care. And this is, you might be familiar with discharge to assess, intermediate care essentially, which is time limited to a few weeks to support these individuals either in a bedded care environment or at their own homes regain some of their independence so they can live at home or perhaps be transferred to a long-term care in residential nursing home. So we'd been developing a simulation model to demand and capacity model, essentially, this pathway, so we could understand what-if scenarios relating to different levels of demand or capacity and look at questions relating to perhaps the need for time-limited kind of agency, remember the term for it, but very short bursts of additional capacity, essentially, that we procure at short notice. And we'd been finding a need to use the simulation model that we had been using for longer-term steady-state modelling in a more operational, immediate way. So, for instance, every week or every month, we'd be wanting to run it for a couple of months ahead and look at how much occupancy and queue size we'd be getting along this pathway. So when you're using a model in this sense, you can start to you can project forward and play in an arrivals trajectory in terms of patient arrivals into that facility in the coming weeks. You know the length of stays from previously calibrating a distribution on historical length of stays of patients going through that service. And that's fine for simulating the future arrivals and discharges and occupancy of patients from that point onwards. But remember, you've also got patients who are there in that service at the moment, okay? And our data didn't tell us how long those individuals had been in that service for. We just knew there'd be 20, 30 or 100 individuals in service at that time, at that moment in time when we were looking to run the simulation model. And this is quite typical. We will have aggregate data in real time, increasingly in the NHS, but not the patient level data in real time. So this is a conundrum. It really matters in the simulation how long those individuals have been in that service, their partial length of stay to that point, because that affects, obviously, how long they're going to remain in those beds, and this could be for a number of weeks. So that's going to affect the occupancy, the queuing, etc., the pressure on that service, the load of that service in that horizon we're looking to model over. So as I say, we put this to one side about 4 years ago, and we came back to it about a year ago and got a solution. So that's what I'm going to be talking about today. So just to kind of go over for those not so familiar with computational simulation then, so there's really a couple of main types of simulation. We're talking about continuous simulation, otherwise known as system dynamics. So this is kind of the stock and flow models that is more useful for higher level system level modeling, let's say, where it's the feedback loops or whatever it may be that's important. And roughly I turn this dial, it goes up or down. That is the kind of outcome of interest. And you've got discrete event simulation, which is more event-driven, maybe for smaller problems, more accurate, requiring more data, of course, appreciating stochasticity and variability and so on, and modelling in a very different way. Rather than looking at it in differential equations and those flows, we're looking at discrete events in time. So first of all, why simulate at all? So a couple of examples might be you're just about to start up a new service or a new pathway and you want to know how it might perform and how you set up that pathway in terms of the capacity and the flows and discharge arrangements. Or it might be you've got an existing pathway and you want to improve it. So you want to look at some performance measures or costs and improve those by recalibrating that pathway. So ultimately, we can't assess these things in real life. You know, there's ethical reasons, there's time reasons. So this is where simulation can be helpful. It allows us to play these things via a computer to understand the effects without having to do any real life experimentation. And there's a whole load of, you've got the Operational Research Society, which is very active here. You've got the Journal of Simulation and various journals. You've got books on it. You've got loads of literature reviews on simulation modelling as well in healthcare specifically. There's hundreds and hundreds of thousands of papers out there on this. And there's lots of tools that can implement simulation, simulate. These are some proprietary ones on the left there, and of course you've got R and Python offers as well there on the right. Or you can code it from scratch. So discrete event routine here, very simple one. Essentially, really, we've got two loops going on here. We've got then a smaller loop, which is iterating over the events, assuming it's an event-driven simulation. So we're going round and we're saying until we reach some time in the future, we're just going to keep simulating events over and over again. And each one of those events typically would be subject to some probability, some distributions that you're pulling from. And each time you do that, it's going to be different. So each one of these replications is a different way things could pan out. And the big loop then is going around and changing that random number seed. So you're generating lots of replications on how things could pan out across that year or month or whatever. So digital twins, this has come around in the last couple or so years, really. And you look on different websites for these different companies and organizational consultancies, and they all say something different. And I sometimes wonder whether there's a purpose in that to confuse people, so you could then go and say, well, I've got all of these questions of what this is. We need to get your services to try and work it out. But actually, when you look for it, really, it's essentially just a simulation. And what the key things when you pick out from people who sell digital twin modeling is that it's a focus on the operational, on the real time, more than where traditionally simulation has been used. So traditionally, we've been looking at steady state simulation. So what we're doing here, system starts empty, we warm it up, so we're simulating events. When it's stabilized, that's our result collection period. We're then looking at averaging those results over those different replications there. And that's what we then model in various different scenarios. So steady state simulation typically used for modeling systems, process or pathways in a strategic sense over where longer term behaviors of interest. So an example here would be in BNSSG. We've done in recent years, last year, a major stroke reconfiguration where we changed our previous model of care where we had 3 ways into the stroke pathway to just having 1 way in through a hyperacute stroke unit. And this was supported by the modeling that we did, where we basically looked at simulating this in steady state for many years into the future. Okay. But what happens if you want to regularly simulate something on conditions at a particular time? So what I was saying at the beginning there, essentially in that example. So it's a very, very different question. So say we're looking at ED occupancy, and this is the occupancy up to now of our ED unit. And the question is what's going to happen next, let's say. So it could go down, it could go on a bit, or could go down and then up a bit. So our problem is simulate ED occupancy over the next however many hours or days. So what's going to happen next in this situation? So let's first have a little think here. So the occupancy at time t, as I was saying at the beginning, so whether that's 6 hours ahead, it's going to depend on the new patient certainly being admitted in that time, okay? And as well, some of them might have been discharged within that time as well as the drain of the existing patients at time now, basically, where we are at the moment. So how many you've got in now, how quickly they're draining over time. And that's affected by, like I was saying, how long they've been in to date. So essentially, we've got then the future occupancy projections. It's the occupancy of the future arrivals, and we've got some information there we can use to model that forward, and the occupancy relating to the current patient drain. And we need some information on the current patients. We need to know the number of current patients and the current length of stay, the partial length of stay of those. And if we have that information, then we can simulate it with 2 discrete event loops there. So one that is the simulated occupancy of the future arrivals, and one which is the simulated occupancy of the current patient drain. And for the latter, if we do know the individual partial length of stays and we know the overall length of stay distribution, we just condition on survival, if you like, up to that point, and then draw sample from the remainder of that distribution. That's easy enough. But what if we don't know the current length of stays? What if we've only got the aggregate data and we don't know the patient level length of stays there? So that's a crux of all of this. So we don't know this information here. We know everything else. So we need to derive the appropriate sampling distribution of partial service times for those currently in ED, i.e. from arrival to their time now. We know they're currently here, but what is that time duration? And then we're using that to initialize the simulation appropriately. So the starting point of the simulation is ideally as unbiased and as accurate as it could possibly be, obviously, given that we don't know the individual times exactly. So one option is to just perform an initial simulation, if you like, before the main simulation. Let that simulation run in steady state, and then extract from that at a cross-section the partial service times for those that are in occupancy at that cross-section. Okay, so you can do this is fine, and it will give an accurate answer provided you don't have any simulation error, so you've done enough replications, 1 million or 1,000, whatever it might be. But the problem is it's very inelegant, and it's computationally time-consuming to do this. So are there any quicker or easier options out there? So you could say, let's just assume that all of those N patients who are here now in service, in that bed or in that ED, have just arrived. So their partial length of stay is just 0. That's a problem because it underestimates the length of stay, and you're drawing from the remainder of the distribution, and that's going to bias it. Or you say, all of them have been there for a duration sampled by the overall length of stay distribution, but that's the overall length of stay distribution until they've completed their length of stay, not partial length of stay. Moreover, both of these would not take into account of length bias. So if you take a cross-section of a population, then you will find more older people in by virtue of older people living for longer and therefore having more chance of being represented in that cross-section. So if you look, following the population demographics chain then in terms of the literature, you find an interesting finding from about 50 years ago, where it's basically a result for the mean current age of a stationary population, although that is a stationary population, that is the mean, not the sampling distribution. So according to our literature view, a solution has not yet been found to this simulation problem, which is a problem that I think is very important to NHS as we're doing more operational modelling, as we've got more real-time aggregate data and more ability to schedule simulation models on service to be able to look at this problem in near real time. But it has got a solution in population demographics. So Luke and I were looking around in very old literature on population demographics, and we found an interesting formula that essentially is exactly the same as our problem, but obviously in a different context. So this is the distribution of age within a population, and it's given by this formula. And this, essentially, it's the probability density of a subject being born at time TR before the current time, so when individuals are being born in an aggregate profile, and then the survival function, which is essentially our length of stay distribution. In this case, it's the life expectancy distribution. And if births, i.e. the numbers being born over time, is constant, then of course the HTRs are constant, and they cancel out of the numerator and denominator there. And it reduces to just a function of the survival time over the integral of that. Now, we can apply this to our problem then in simulation. It's essentially a one-to-one mapping, really. So instead of thinking of age, we're talking about current length of stays, and we're talking about a cohort of currently admitted patients instead of the population. And we can use the same result. So basically what these results are is the sampling distribution then of the partial length of stays that we can sample from in order to then calibrate, initialize the simulation, to then run the simulation. So this is very easy to implement in R. It's a few lines, and it's probably a similar thing in Python as well, I'd guess. So this is the code assuming time homogeneity, i.e. the births to date have been constant over time. So I don't necessarily need to go over this, but essentially this is the survival function. This is I think there's a log normal distribution here. We've got, well, that's the survival function, and we've got then the various integration that goes on there coded up. And then we just call this up, and we're looking for then 10 draws. So say we've got big N is 10. We've got 10 individuals we want to obtain samples from, given this is the length of stay distribution and so on. And these are those samples. So we can verify this formula holds by using the preliminary simulation method that I said before was accurate, provided enough replications. And we can see here, picking on 3 length of stay distributions to get an idea of sensitivity to the shape of a length of stay distribution, that when you run for each of those 3, there's overlap in the formulae versus the simulation. So it's verified, it is doing what it's supposed to be doing. Well, the question is, so what? What difference does this really make? So let's perform a simulation now via the initialization as per the formula, as well as those 3 workaround methods that I mentioned earlier. And let's see how the results of this simulation then change based on those different initializations. So let's first look at time constant arrivals. So we have a graph here where we're simulating 10 units in time, see the calendar time on the bottom there, and the columns are the different methods, and the rows are those 3 different distributions that I talked about. So what we'd expect with time constant arrivals is that, oh, and big N is 50 here, so that's why it starts at 50. So we've got 50 occupancy, let's say. Occupancy is on the y-axis. Now, with time constant arrivals, you'd expect it to be the same all the way throughout. And it is for the exponential because of the memorylessness property, of course, but you play in the log normal distributions, the second and third rows, and you can see that things go way out of kilter there in the initial times especially. That's because you've initialized it poorly, wrongly basically, via those quick workaround solutions. So we can see here that the formula provides the results to expectation, that it is then constant in time, and we don't see that disturbance initially that we see in the others. And as I mentioned, yeah, this is all the same because the memoryless property doesn't really matter. But for these ones, we're seeing big errors there. So if you initialize it using a workaround rather than the appropriate closed-form solution per the formula, we can get double-figure errors there in percentage terms. So these are wrong, basically. And we can see this looking at time variant demand as well. So if here we've got cyclical demand, so this may represent the ED arrivals over time, going up and down each day through the hours of the day. And here we look at a formula that basically just plays in that cyclicality there. And we can see here that the problems still exist. Here they're even bigger. We've got up to a third error there in that initial period of time in the bottom right graph there, where we've got a slightly heavier tail in that log normal distribution. And there's various reasons that we can explain around this, but which is too much to go into at the moment. So it's basically a problem. If you use quick and dirty methods, they're going to get you into trouble, especially in the early time, where arguably use of digital twin or online or symbiotic simulation is the most valuable. You're doing it to understand what's happening more often than not in the near term, rather than the 10 units out. So concluding then, I think there's a massive opportunity for this kind of real-time digital twin, as I say, simulation modelling or online or symbiotic simulation modelling in the NHS. We've got more real-time data. We've got servers that we can schedule models like this on for real-time use. And we've got a hell of a lot of urgent care pressures which require operational solutions like this, rather than one-off modelling exercises, something that could be used online, that can update every day or every hour of every day on a server, recalibrating to the latest data. The challenge, though, is that much of the real-time data is aggregate and not patient level. If you had it at patient level, you wouldn't need any of this complicated maths, because it's just simply you sample conditionally on the distribution, knowing those individual times to date. So this can prompt difficult conceptual modelling challenges, as they're shown here, and the inappropriate workaround solutions can have big errors up to a third. And you look around and there's often a solution there somewhere that you can find, that you can apply to your problem, perhaps having to go back decades in other literature, as we've done here. And we're using this model in our IPACS complex discharge model. I'm sure, very confident that in years to come we'll start to use this approach for other applications as we go. So yeah, thanks so much. Thanks to the conference organisers as always, and mine and Luke's emails are there if you want to contact us.
Thanks, Rich. We've got quite a few questions coming in on Slack. I'll pick a couple out. So there's one here from Chris Maney. How do you estimate the uncertainty in a discrete event simulation model? Is it through repetition, averaging across simulations, bootstrapping, or something else?
Okay, it depends what uncertainty you're talking about. You really don't want to have any uncertainty related to the simulation itself, so make sure you do enough replications on that, and choosing the sufficient number can be difficult if you've got low varying distributions like exponential distributions in your simulation. Then you might not need to do as many runs as if you've got very heavy-tailed gamma distributions or whatever it may be, just because the chance of getting one of those tail events skewing your results increases with the greater variabilities in what you're feeding into the model. So of course, yeah, in terms of uncertainty related to the simulation itself, you want to reduce that as far as possible, as far as your balance between your computational limitations on time might allow. Then otherwise, of course, it's a stochastic model inherently, so you're going to get uncertainty in terms of the confidence bands shown there, based on just the way different things can pan out during the course of that modelling horizon that you're looking at. And you represent that via confidence bands or whatever you want.
Thank you. Another one from Emily Baldwin. Really interesting solution. I was curious if there was interest from the provider to co-produce the tool so it could access the record level data in real time.
Yeah, that's a good question. Yeah, I mean, there are some things we've been doing. My colleague Nick Howlett's been doing some modelling for daily level modelling on basically kind of discharge requirements. So simulation modelling in a hospital, looking at when patients will be ready for discharge for the different pathway 1, pathway 2, and pathway 3 of the D2A pathways. And for that data, we've been for that modelling, we've been using a local flow we've got from our acutes, which is patient level actually. So that is one where we do have patient level data, and then what Nick does in the modelling is then condition on those length of stay distributions using that patient level information. And that's not always, and FDF, faster data flows, could give a route to doing that kind of thing in similar areas around the acute care, but it's not always a luxury that we can rely on to have that patient level data.
Thank you. One more question. There's plenty on Slack, but I'll leave you to answer those offline. There's one voted here from Daniel Chalk. Have you considered the potential for reinforcement learning to couple with a digital twin model to feedback the real-world impact of decisions being made based on the outputs for the digital twin model? So could we use reinforcement learning in some way?
So in one word, no, we haven't thought about that. It's a good, it's a good, I mean, I guess depending on the problem, some of these things may be more prone to change in time or more slowly over time. And certainly where you've got factors that could be more prone to changing over time, then calibrating or recalibrating the ingredients here, which would be the length of stay distributions, could be done routinely. So we have other models that we recalibrate automatically every week with the latest data in order to try and learn from the latest patterns we're seeing coming through in that data. So it really does depend, but I mean, it's a good question in terms of ensuring that a model is learning from what it's seeing. In terms of the feedback from the decisions, that's a more tricky one.
Cool. Thanks, Rich, again. Thank you, Rich.
Thank you.
Fortunately, I left my bow tie behind. Oh, perfect. And here's the talk. So I'm going to be talking about how we made a one-stop website for the statistics in the department using open source coding languages. So if we go to the next slide. Ah, perfect. My bad. Perfect. What is TIN? Transport numbers. So basically, as mentioned, it's a one-stop website to present all of the statistics that are produced by the department in one place, broken down by a thematic and cross-modal lens, i.e. just different topics. This is as a result of a piece of user engagement we did a couple of years ago, which highlighted some difficulties that users found when trying to navigate and use our statistics. So what TIN is trying to solve are some of those issues where you can see some of the benefits on the slide. So for example, presenting the story first, i.e. the data, rather than trying to get users to navigate through the maze that is gov.uk. And if anyone has used gov.uk, you might understand what I'm talking about. Self-serve for different user types. So we can allow, for example, with TIN, to address different user personas. So, for example, your general inquirer who just wants those key stats, so that could be policy, could be the general public. Or you could drill down to those who are more technical, who want to either get into the nitty-gritty of the detail or do their own personal analysis using the data. The other two are up-to-date trends and topical themes. So, with publications, there's usually quite a bit of a lag in terms of getting the data in, getting it QA'd, ensured it's accurate and robust before it's published. And for some compilation publications, that can mean there's a longer time period lag between the latest data and when the public actually sees it. And the relevant themes and topics is basically, for example, when it comes to like COVID or strikes, for example, if we collect data on this kind of area, we can then present it in we could get that data out basically. And this is what TIN is trying to resolve. One, presenting that latest data more timely to users, and also having the flexibility to show different topics which might be of use to internal colleagues and also external, so like the public. And if we can switch to my laptop, perfect. So here is the website, a couple of caveats. At the moment, it's only published within DFT at the moment. I'll cover a bit more detail as to some of the details behind it. And also, if you're after any government secrets, unfortunately, I can't divulge in that. This is all published data, so sorry. Hello. Whilst that comes up, if you guys remembered, when it pops up, that was basically the home screen of Transport and Numbers. So if you remember that, oh, I think I might know what's going on. It could be my screen. Let's see, hopefully now it can return. There we go. Okay, my laptop just went a bit dead. So as you can see on the screen, you can see the mouse, that helps actually. What we have are some topics. So at the moment, it's still a work in development. We're working to expand the content in TIN to cover more topics and themes. But you can see the kind of topics that we're showing. So different interests from currently internal department. And on the main part of the page, 3 key stats for each of those sections. So trying to address that kind of more general user interest. If you click into one of the sections, for example, how we've done it is each part has a title. It has a key message behind the data that we're presenting. And as you can see, there's a chart, the underlying data behind that chart, and some key information behind the data source itself. So whether that's key caveats or terminology, that information is provided. On the right, we have like data source, the raw data, well, the published data, I should say. So if users did want to go into more detail, they can. Information about when the data was last published, so addressing that kind of timely need, so users know they're using the latest data, and contact information, so people can get in touch with the right team. I'll just quickly scroll through, but essentially these kind of sections are repeated. The format is basically the same, relatively simple charts, trying to effectively present the key stats similar to what has been covered in previous talks today. And this was done with intent. So we adopted a modular approach, and all of these pages are actually made using R Markdown, static R Markdown files. If we can go back to the slides, I could go over a bit more of the process. Thank you very much. So here's the overview of the process. Basically 4 broad areas, just keeping an eye on time. The first one is getting the raw data, so that's information from gov.uk, and I'll mainly talk about the tables as that's the main thing that's taken up a lot of the processing power, basically, as you'll find out in a bit. So yeah, get the information from gov.uk. The next step is getting that information from gov.uk and in a platform which stores that information in a way that we can then communicate that using other languages such as R, Python. So first we web scrape the information, get that into temporary files, and then download the files into Google Cloud Storage buckets using Python processes before using R processes, I'll cover this in a bit more detail, to move that information into BigQuery. The third step is analyzing and presenting that data, so what you see or what you saw in that demo of the website. And the final step is actually publishing it so people can see what's there. So I'll quickly cover in the, just being aware of time. First step is the raw data. So we publish around 100 publications each year, I believe, and over 1,000 tables. So that's quite a lot of processing power in itself. So one of the things we had to bear in mind is that basically we can't develop a process which was too demanding without it slowing down the processing power of the tool. So All of that information is on gov.uk. I'll quickly move on to the next step, which is the more interesting part potentially, how we get that. So I mentioned that we used Python in order to get the information from gov.uk into Google Cloud Storage buckets, for example. This initial step was actually done mainly in R, but we engaged with data engineers within the department. So one thing I forgot to mention, all of this work is being done internal to Department for Transport. Nothing's been contracted out. So it's been a lot of reliance on and development of rapport and relationships between those within the department in order to try and develop this. So with the help of data engineers, we were able to develop a more robust and reliable process in order to get this data in, one that's more efficient. And unfortunately, I can't give too much more detail because I'm not a data engineer, sorry. But if you've got any questions, I could try and help. The R code is there to, once the data is in Google Cloud Storage, the R code then cleans the data, extracts the information that we need, and transforms it into a tidy format. And the good thing about the code is that we've developed is essentially it works for all the tables that we've published. So I'm sure there's some very weird tables out there that the code might struggle with, but part of the efforts that we've done to do with this work is to make sure our tables are accessible and also follow a consistent standard. So, for example, no merged cells, no split cells, no hidden rows, etc. And this makes it a lot easier for R to communicate with ODS workbooks and be able to get the relevant information and put it into tin, essentially. And once it's been moved into BigQuery using those R processes, then we do move on to the next step. Before I move on, we use Cloud Run to schedule the initial web scraping of the information from gov.uk, so that's using the Python processes. And most of the R functions that are somewhat referenced on this slide, they can be found in the publicly available repo, as you can see on the bottom of the slide. Links provided, so I think if the slides are shared, which I believe they are, perfect, you'll be able to check out that code if you wish. So yeah, just move on to the next slide. So analyzing and presenting, I'll try and hurry up a little bit. The majority of this is done in R. So this is creating the chapters or the web pages that you saw in the demo earlier. That also includes creating the charts, creating the key commentary that we present, and also populating all of that metadata into those sections within the pages. So like the contact information, the latest date of publication, etc. We also used HTML, CSS, JavaScript, and also Gov-style components, which are published in order to replicate that gov.uk feel. And as part of user feedback, it has been mentioned that having that is very useful. So it assures a sort of trustworthiness of the website. So people know that they can trust what's being presented as another form of assurance. And also GitHub for that version control. There's another aspect of GitHub, just because of time, I'll skip that slide. There's another aspect of GitHub that we've used for this, which has proved to be very valuable, and that's through the use of GitHub Actions. The main part of this is being able to deploy the website on GitHub. This also acts as a way for us to QA it before we publish it around the department. So ensuring that, one, the website actually builds, two, all the functionality is there, and three, it allows us to QA the actual content. And that final step, to get it out to colleagues in the department, we published the website via RS Connect. A couple of the challenges, we're out of time, so I won't cover all of these for the next two slides, which are the last two. But some of the main challenges that we've had are, as you can see and mentioned, handling different data types. So we mainly publish ODS as an open source form of data. And as mentioned, before we rolled out a more consistent approach for teams to adhere to, it was quite difficult handling inaccessible tables, especially when trying to automate it. Logistically, it's a very big project for a relatively small team. So at most we had about 7 people working on it, and at the moment we've got about 3 or 4 consistently working on the website in order to maintain it. And as part of that, as you see on the slide, there's several aspects which follow on. So, for example, engaging with teams, making sure that the data experts, i.e. the stats teams who actually develop the data, are able to QA it and make sure that all of the information there is accurate and reliable. Future plans, just quickly cover it. The next immediate steps are to expand on some of the chapters. So we've been working already with some of the stats teams in order to generate this content and make sure that it's valuable to users. So this is part of why it's taken quite a long time as well, as part of the challenge, because in order to make sure that we're presenting information that's actually useful, it requires working with stakeholders, key stakeholders, to make sure that the stories hit. And finally, linking up the back end so we can actually make this a fully automated process. Long-term plans, the main one is basically publishing it so it's public facing. So like I said, currently it's internal facing, but the long-term ambition is so that it's published for all use. The other one is we'd like to try and develop, well, we will try and develop templates. So at the moment, that TinScrape public repo is available, but the code behind transport numbers itself is currently a private repo. Long-term ambitions, again, try and make it available to others, so it doesn't need to be stats, basically, that's presented. It doesn't need to be transport. It can be health. It could be education. It can be management information. It could be qualitative information. It just doesn't need to be stats. And so by having some sort of consistent approach and a template for users to use would save a lot of bother and help have that consistency across products. And I'll finish there. My email is at the bottom of this page. If you have any questions, do let me know.
Thank you, Mohan.
Thank you.
Yeah, lots of interest in Slack for a very cool project. The top question is, what's the reason for using Python to scrape, download and store, but then to use R for the other stuff? Why did you decide that as opposed to just using one or the other independently?
I'll try and answer the Python side. So when discussing with data engineers, I think it's more of a, for want of a better phrase, a more traditional approach to use Python for essentially the web scraping and getting that kind of information from, in this case, gov.uk, partly because of computational processes, partly because of efficiency. In terms of why we then used R for the vast majority of it, so even the Python code still refers to some R code. Python within the department is used mainly by data scientists, data engineers, whilst this project is actually a statistics-led project. Say that 5 times very fast. So across the community, we mainly use R. So in terms of resilience, so being able to delegate chapter creation and making sure that the right information can be developed, we can then ask the teams and delegate that out and give them control, essentially, because they know the data and they know what's of interest. So a bit of a digression, but hopefully that answered that question.
Awesome, thank you. And one more question, again, there's more in Slack for you to pick up offline. Have you done any user or accessibility testing?
We have a bit. So the main tests we've done have been screen reader use and also color contrast. So all of the charts, all of the charts in TIN at the moment use an accessible color palette. All of the functionality we've tested, like I mentioned, with screen readers and also without the use of mice. This is something that we've been rolling out quite heavily across the department, not just across TIN, but also across publications. So this is also part of, I believe, government digital service requirements. So when we do go out to public, we will be following certain standards and making sure that we're following accessibility guidelines. This will be part of it, so yes.
Awesome. Can we thank Mohan again, please?
Thank you.
I was just about to do my best Annika Rice impression and go grab Colin, but he's already ready. That is an old reference. Do we have slides up for Colin? Oh, fantastic. It's the talk you've all been waiting for, quite literally. Colin Gillespie.
Thank you very much. Sorry for the mess up. So who am I? I'm almost an ex-academic, so I've been in academia for 20 odd years. I'm still 1 day a week. I still see students. So I had undergraduate students yesterday. They all look so young. Co-founder of Jumping Rivers, so we've got a little booth outside, and I've been using ours for about 25 years, which makes me officially old. We've got a Shiny conference, so if you're interested in anything Shiny, that's both R and Python. That's happening in October, and there's a ridiculously cheap rate just now. The catch is we have no idea who the speakers are, so they'll be good because they've been good every other year. Right. So start with a bit of confession. So we do lots of training courses, and some clever person always goes, "Oh, but how can you trust this? You're using dplyr. Can we trust that? Or using this? Can you trust that?" And what we do is, well, we wave our hands and we waffle about Cran's safe and nothing bad has ever happened, and we wave our hands, and then we sort of go, well, it's just common sense if you really think about it, of course it must be okay, and then we change the topic to something else, and that's worked, if I'm perfectly honest, for a good 10 years, and no one's spotted that it's all about hand-waving. Doesn't seem that great though, does it? It's sort of, could do a bit better. So can we trust an R package? And you can substitute Python in here. So everything I'm going to talk about applies to Python as well. So can we trust an R package? And it depends on your risk appetite. Right? So the word trust implies it's either good or bad. And I think that's just it's a wrong way of thinking about it. Right? So it depends on your risk appetite. How comfortable are you with the risk of using something? Right? And Rhiannon made an Annika Rice reference. This is a Dirty Harry reference, which I realise is just so above the head of almost everyone in this room. But do you feel lucky, punk? Find someone, one of your seniors, and you can ask them about that reference, or go on YouTube, or whatever the kids use these days. Right? So do you feel lucky, punk, when you're choosing an R package? So let's go through this. So we've got risk appetite. So on one side, we've got students who, if we're perfectly honest, don't care. Right? They just get anything and just install stuff. Right? And then we bring them into organisations and we wonder why think, let's move on. And then we've got academics who pretend they care, but we don't really care because we've just got a paper that we just want in Nature, and that's all the be-all and end-all. So we sort of pretend to care, but then we get a publication and then we do a runner. We've got startups that sort of care, but they're really more interested to actually have a job the following week, so they've got other things in their mind. We've got sort of government, and they're just sort of using that as a vague sort of term, which is most people in this room, something to do with the public sector. Could be utilities, sort of government, could be trains, anything in that sort of sphere. And then on the other end, we've got finance and we've got pharmaceutical companies. Okay? So on one end, we've got students who don't care at all, they just want something and they just install everything. And then we've got pharmaceutical companies where if they get something wrong, something bad is going to happen, A, to perhaps patients or the population, and B, to people in the company where they might get sued or imprisoned. Right? And so this thing here, we've got sort of validation on demand, and that's just sort of my idea of all these companies in this sort of right-hand side sort of want someone to say, this is okay, you can use this is fine, it's okay. And then if you're really on the extreme, you're also talking about validated environments, right? So it's not just good enough to say dplyr version 1.5 is great. You have to say dplyr version 1.5 on Ubuntu 22.04, when I ran it in this cloud, the whole shebang, right? Be really precise. So, I think since I'm now on the last talk, we can get some audience participation. So have a look at this, and where do we think that NHS is on this graph? So maybe 3 seconds to think, and then I'm going to get you to put your hand up. So, who thinks you have to participate, right? Because otherwise you look like a complete prat. So you have to participate by putting your hands up. You can stand up as well, but I'm happy with hands. So hands up if you think the NHS is on this side. Okay. So what's that? 10% of the room, 20% of the room, would you say? Hands up if you think you're on that side. Okay. So does that mean everybody with the hands, I can come and say, can you show me some audits to do with what packages you're using? Anyway, so I would say that the people on the left are correct and the people on the right. So everybody's correct. Well done. We all get a participation prize. Why do I say that? Well, just listening to a few talks and looking, abstracts and everything else, you can see that some people in this room are sort of doing experimental stuff. They're just trying to figure out what's going on. It's not that it's not important. It's just it's sort of there's one or two barriers before it hits patients. They're just trying to understand things. And then there's other people in the room where what they're doing can directly impact patients pretty quickly, right? It's not quite the same. And you can also think about if you're building a dashboard, the level of trust you want about the thing you put in production is not quite the same as the thing that you're sort of using to build. So you can imagine iterating over lots of different dashboards, having a bit more relaxed view, but then when you're going to the production environment, you might think, right, now we need to tighten up and make sure everything's okay. And that's a reasonable thing. So let's think about package risk. So here's a little package, so dplyr, and again, substitute your own favourite package. Interestingly, maybe not, depends who you are, we're talking about a package, but this has got a whole bunch of dependencies, right? I'm going to make the number 80 up because it sounds quite big. So let's imagine this has got about 80 dependencies. Are we just caring about that package or all other 79 dependencies? Right? So it's a question for the audience later. So this goes into, so we've been working with a whole bunch of pharmaceutical companies, and essentially they have to, when they say, we think dplyr is okay, what they have to be able to do is when someone says, okay, prove it, they have to give them a big bit of paper to say dplyr is okay because of all these reasons, and it's validated. So what happens here is we've got a bunch of assessments, and everybody agrees about these assessments. This is the great part, because nobody disagrees. So I think everybody can agree that a valid package should have some examples, and downloads is somehow important at other people using it. And does it pass our command check? And does it have some sort of code coverage? So everybody, I think, agrees that these things are important. Everybody disagrees about how important they are, right? So if we're talking about unit test coverage, is 20% okay? What about 40%? 60, 80, 73, 95, right? You get the point. There's a variation. We've all got sort of different opinions. And so essentially we can take all these assessments, and there's a whole bunch more, and you can start thinking about putting them into scores. Right? A bit like a p-value, but I'm a bit Bayesian, so I don't want to say those words out loud. But you can think of sort of condensing them into a single value. And then you can get an overall score. So now you can think about ranking all these packages. That's great. And then we've also got a way of doing high-risk issues. What does that mean? Well, if you take dplyr, let's imagine it's a bee's knees, which obviously it is. It's got great unit coverage, it's made by POSIT, everything else, but there happens to be a security vulnerability. So even though it passes all these checks, you still want that little thing to jump in and go, oh, actually you should have a little think about that. Okay? So this is a sort of idea of how to do this stuff. So, do you feel lucky, punk? I would say lucky's nothing to do with this, right? You're trying to manage your risk, right? You might be, I suppose, unfortunate, or if you've managed your risk and still something bad happens, but you've thought carefully about how it happens. You've thought carefully about what you're doing. What I would strongly recommend is always getting away from this idea of you have a set of validated packages that some group decide. Because what's good today has a tendency of being a little bit sticky. And so in 6 months' time, you're still using the stuff you thought was good today. And in a year's time, you're still using the stuff that you thought was good today. And in 4 years' time, you're still in R version 3.2, and you're complaining to IT. So have a little think about how to sort of process this. So, how are we doing it? So we're developing something called the Litmus Framework. And this is a big picture, so it's all going to be, I'll rephrase that, most of it's going to be open source. We're still trying to figure out which bits, but all the important bits will be open source. So we've got a Litmus package, and that looks at a package, so it ingests a package and produces all these assessments. I now have a whole talk on how to parse the bugs report URL in a description file. I'm not joking, right? It turns out you look at your own package and you think, it's not that hard to get the title or whatever. Once you go for 20,000 packages in CRAN, everyone's got a slightly variation. So that takes care of all that stuff. We've then got individual scoring package. So essentially, if you've got a whole bunch of assessments, downloads, unit tests, security, then this score, each organisation might have a different scoring package, might have more than one. production testing. And so then you can produce a score. We've got an idea about reports, obviously, so you ingest this, you produce a nice PDF. Organisations like PDFs, so we can produce lots of them. We've got an idea about containers, so if you're really interested in running it in you know exactly what it's running on. It's not just in Colin's laptop in Starbucks, it's actually on a well-defined container under a well-defined operating system using everything else. We can do that as well. This part here, we're currently writing an application, and we'll have a sort of a public version. And the idea here being is, we've already went through all of CRAN, we've got all these metrics, we've got all these scores, and you can have a look at them and try and figure out where you're wanting to draw the line. So that's where we are. So this is going to be sort of open source round about 2025. This last point is more for pharmaceutical companies, I'm guessing. But essentially, if you're a pharmaceutical company and you've got a package with no tests, they're wanting someone to say, well, can you write some tests for it just to make sure it's okay? Right, that's really important, because FDA, big organisations say, show me the proof. You said it's good, show me that proof. It's not just good enough to say it's okay. So that's all I've got. So I think it's quite good because I'm short for a change, and it's the last talk. So thank you very much. Any questions? I'm happy to chat. I'll be here tomorrow, and I've got a booth outside as well. Thank you.
Thanks, Colin. Yeah, there's lots of questions on Slack. Really interesting project. The top question, though, is how do we trust Litmus?
So, very good question. It has over 600 unit tests, which is absolutely ridiculous, 100% code coverage. So every time something is broken CRAN, so we started by starting in the letter A, and then we got to AAC or something like that, and it just broke. And so every time something's broke, we've put that back into Litmus, we've got a proper test, and we've tried our hardest to make it robust. Because it is a very good question. It's an obvious question of who checks this stuff. So all these stuff has got 100% test coverage.
Cool, thanks. Another question from Seth Fox. Does it only work on CRAN packages, or, for example, there are also ROpenSci packages that aren't on CRAN, etc.?
So it works in any R package. So the idea being that CRAN's not that, it's obviously special, but it's not that special. So it doesn't matter if it's CRAN. It's more of, do you score that package more or less because it's in CRAN? So you've got a scoring function. If being on CRAN makes you happy and joyful, then you give it a bit more of a score. If you really don't care, you give it less of a score. You're still doing all these other tests, such as rcommand check and does it have a maintain and everything else, but it's just an extra piece of information that helps you.
Cool, and out of interest, have you run it on any sort of like packages like the Tidyverse packages? How do they fare on something like this?
For the most part, they fare exactly how you'd expect. That with the exception, there's one or two. Once you start going into dependencies, you then start using. So I think it might be Shiny or something like that. It's got a dependency where essentially it's also been made by POSIT, but the unit testing's quite light. And so pragmatically, what you do, you think, well, they're made by a company, we trust this company, it's okay. But these other metrics, they're not okay. But again, you can document that choice. It's a risk. You go, I'm okay with that risk, or no, this is terrible, but that's okay.
Lovely. That's great. Thank you, Colin. Can we thank Colin again? And to close today's ceremony, we've got Zoe Turner.
I'll be incredibly short. No slides. We're gone to the thing. Just a quick thank you to everybody here and online. Sorry we went a little bit over. I think we kept to time. There was a few changes, technical issues as they are. I hope you've enjoyed today. Just to say, tomorrow, for those who are coming back, in person, 9 o'clock for registration and coffee, as it was today. And for those online as well, come and join us at 9:45. That will be me talking, so hopefully I'll be here. And then we will continue with another round of fabulous talks. Thank you to everybody today, and we will see you tomorrow. Thank you very much. So I'm hoping that's a cut of live stream. Otherwise, this will not make...